Alright, so we're going to continue our work in section 1.6, which has a lot of review topics, and these sections are just crammed with stuff, especially if you don't remember everything from intermediate algebra, which most students don't. But let's remind you of some things. So first of all, we have what's called the zero property. If you have two numbers and they multiply to 0, then one of the numbers has to be 0. In this case, it'd be either A or B. And so the same kind of thing is going on here. You actually have, you can think of this as three products, or I should say three things multiplied. Really, you could think of it as 4 times x, but we'll just call it 4x times x plus 3 times 2x minus 3. So if these numbers multiply together and you get 0, it's either the 4x that's equal to 0, or the x plus 3, or 2x minus 3. So we got to solve these three equations to get our solutions. Well, 4 times some number is 0, that would be 0. Here we'll subtract 3 on both sides, we get negative 3. And here we're going to add 3 to both sides, we get 2x is 3. Divide by a 2, and so x is 3/2. And so our solution set, we would write as this, it'd be negative 3, 0, and 3/2. So we have three answers here. Alright, so look at number 4 now. One of the things you find with this property is we need 0 on one side. And so we want to get this 12 out of here. Let's add 12 to both sides. We get 2x squared minus 14x plus 12 is equal to 0. Notice with these three terms, none of them were like terms. So you can't add any of them together. All you can do is write them in what we call descending order. We got the squared term, we've got the x term, and then the constant. Now, if you remember your factoring, there's a number of different kinds of factoring that you should be familiar with. One of the first ones you learn is if there's a common factor, you want to factor that out. And that's what we want to do here. You don't want to jump right into factoring this trinomial. We could factor out a 2. Whoops, let's make that a 7. So let's focus on this part right here. Now, whenever you have a 1x squared in a trinomial like this, it's pretty easy to factor because you know x times x is going to give you the x squared, and we just need to find two numbers that multiply to 6 and add to negative 7. Or you could think of it as your AC is 6, 1 times 6. Maybe I should do this here. What we're really factoring here are trinomials of this form with three terms. Your AC is this number times this number here. It's 1 times 6, or 6. And then our B term is negative 7. It's just the x term. So we need two numbers that multiply to 6 and add to negative 7 to do a problem like this where you have a 1x squared. So 1 times 6 and 2 times 3 are the only ways to get 6. We need these numbers to add to negative 7. Well, we know that the numbers could both be negative and still multiply to 6. So since they add up to negative 7, they must both be negative. Negative 1 and negative 6 do add up to negative 7. So it's going to be a minus 1 and a minus 6 here, times the 2 out front. So notice you have three numbers that multiply together and give you 0. But it's not because of the 2 that this product is 0, it's because of one of these factors here. Multiplying by 2 doesn't cause a product to be 0. So we can set x minus 1 equal to 0, and x minus 6, and we're going to get 6 and 1. All right, let's move on to number 5. So here, this is not a 1, so we're going to use the AC method here, but it's a little bit more involved. Our AC here is 3 times negative 5, which is negative 15, and our B term is negative 14. By the way, as soon as you find the pair of numbers that works, you can stop. You don't have to be systematic the way I am, but you can be. So I'm going to use all the factors of 15. It's only 1 times 15 or 3 times 15. It's very similar to well, actually it's not quite the same because this time our product is negative. So we're going to have opposite signs here, and our numbers add up to a negative 14. Well, since they add to a negative 14, you should make the smaller numbers negative. Notice this is the one that adds up, or wait, I'm sorry, I said that wrong. Since they add up to a negative, you want to make the bigger numbers negative. It looks like I wrote a 15 there instead of 5. Let me fix that. There we go. So make your bigger numbers negative. Notice this is the one that adds up to negative 14. So we're going to split our B term. This becomes 3x squared plus x minus 15x, and then bring down the minus 5. So basically we're splitting a minus 14x into 1x plus negative 15. Notice those do add up to negative 14x. And so that's the main strategy with the AC method, is you turn it into 4 terms and then you factor by grouping. But the key is finding the right numbers that work here. There's only going to be one answer each time. You got to make sure your numbers work. So we're going to group our first 2 terms and factor out the GCF, which is x, times 3x plus 1. And when we factor the other 2 terms, the last 2 terms, we expect to get the same factor in the parentheses. And so we ask ourselves, what times 3x plus 1 gives us negative 15x minus 5? You're going to need a negative 5. So notice when you multiply, you do get what we have up here. And so now our common factor in these 2 terms is 3x plus 1. You have 3x plus 1 times x here, and 3x plus 1 times a minus 5. So you end up with an x minus 5 here. There's a shortcut that you may recall. You can just cross these off and notice you're left with the x minus 5. That's what goes in here. Now keep in mind, you could always FOIL this to double check that you get what you started with. You can always multiply to check when you're factoring, but I will tell you that it is correct. Let's go ahead now and do what we were doing above. We have 2 factors that multiply to 0. So either 3x plus 1 is 0 or x minus 5. So here you're going to get 5 by adding 5 to both sides. Here we're going to subtract 1 and then divide by 3. And you get x is negative 1/3. And so negative 1/3 and 5 is your solution set there. I probably should be writing or squaring my answers so you can tell what the answers are. All right, number 6 can be solved just like number 5. You could use the AC method, but the other option you have here is you can look at the ends and notice 9x squared is 3x squared, or 3x times itself, and the 4 is 2 squared. And so the easiest way to do this one, assuming that this is what we call a perfect square trinomial, is to try 3x and 3x as your first terms, because those multiply to 9x squared, 2 and 2 as your last terms, because 2 times 2 is 4. Everything's positive here, so put some positives in here. And the only thing left to check is that your inner product and your outer product add up to 12x, and notice they do. So if I FOIL this, I do get what's up there. And so that would be the easiest way to factor this. You could also try factoring by using the AC method. And actually, I'll just real quick, I'll put that on here, the solution here. So if you want to try the AC method, that's what it would look like. All right, let me go back to what I was doing. So once we have this factored, we just set each of our factors equal to 0. And actually, they're the same, so you don't have to do both. We'll subtract 2, divide by 3, and you get x is negative 2/3. All right, so that's the factoring method, and the next two problems we're not going to be able to factor. Now these are quadratic equations, just like the ones above. The things that makes them quadratic is the highest power on the variable is 2. But you could try factoring this, but you're not going to be able to find numbers that multiply to 1 and add to 3. Same thing over here. Numbers that multiply to negative 3 that add to negative 6. And so hopefully you remember the quadratic formula. We have x equals minus b plus or minus square root b squared minus 4ac all over 2a. And so a here is 1. It's understood that's a 1. B is 3. And c is 1. We get x equals a minus b, which is minus 3. Plus or minus b squared, that's 3 squared. Now keep in mind, if I were plugging a negative number in here, I'd be putting parentheses around the negative 3, but it's positive. Minus 4 times a times c, 1 times 1, all over 2 times a, which is 1. And so we're going to get negative 3 plus or minus the square root. Now be careful here, you got to square first, that's 9. Minus 4, we're going to get 5 here. And so it's negative 3 plus or minus the square root of 5 over 2. All right, let's go ahead and I would encourage you to try number 8. It's the same thing. It's just going to be more difficult to simplify. This radical expression can be a challenge to simplify. All right, so let's go ahead and look at number 8. So I always like to write the formula out first and then plug in the numbers, and that's what I tell my students to do so they don't, so hopefully they avoid some silly errors that sometimes are made. So negative b, notice, let's see, a here is 1, b is negative 6, and c is negative 3. So negative b, that's negative 6, plus or minus the square root of negative 6 squared, minus 4 times a, which is 1, times c, which is negative 3, over 2 times a, which is 1. So the opposite of negative 6, or negative 1 times negative 6, is 6. Over here, you're going to square, you get 36, because negative 6 times negative 6 is positive 36. Now be careful here, you're subtracting this product, which is 4 times negative 3, or negative 12. You're subtracting negative 12. Now some of you might just see the two negatives here and just end up with the plus, but you do end up, no matter how you do it, adding 12. So 36 plus 12 is 48. And that's over 2. Now when you simplify the square root of 48, because it's not simplified, well, first of all, you got to remember how to do that. You got to know your perfect squares other than 1, starting with 4, which is 2 squared, 3 squared is 9, and then you have 16, 25, and so on. Now, the reason why 48, the square root of 48 is not simplified is because it has a perfect square factor of 4. Now, if you broke this down into the square root of 4 times the square root of 12, and you wrote it as 2 square roots of 12, the problem you would have is 12 still has a factor of 4. So basically all we need to do is go bigger. 16 is the largest perfect square factor. So let me go back up top. Square root of 48 is the square root of 16 times the square root of 3. And that's 4 square roots of 3. And so we're going to replace the square root of 48 with 4 square roots of 3. So we get, and I'm going to also break this into two fractions. It's 6 over 2 plus or minus, we said 4 square roots of 3 over 2. Well, we're going to finally end up with 3 plus or minus 2 square roots of 3, because 4 over 2 is just 2. And so that's your final answer here. All right, I'm going to stop the video here because we're moving on to another kind of topic, and that was a 16-minute video, so we'll stop right there.